The authority having jurisdiction, OJ, may be interpreting National Electrical Code Section 230.2 A1 as prohibiting multiple feeders to a different building. This section states a single building shall be supplied by only one service. However, it is common practice in many areas to install a single service for multiple buildings on a property, especially when the buildings are interconnected and have a shared electrical system. This approach is often used in situations where single-family homes are converted into multifamily units. NEC Section 230.2 A1 does not explicitly prohibit multiple feeders to different buildings. Instead, it specifies that each building must have its own service. In the case of interconnected buildings with a shared electrical system, the NEC allows for a single service to feed all the buildings provided that the service conductors are sized accordingly. To resolve this issue, you can consider the following options. Firstly, install a separate service for the duplex. This would meet the AHA interpretation of the NEC and ensure that the duplex has its own dedicated service. However, it may involve additional costs and labor. Secondly, provide a written request to the AHA for clarification. Explain the common industry practice and request the AHA to provide a specific code reference that supports their interpretation. Thirdly, contact the utility company. They may be able to provide guidance or support for your request to install a single service for both the single-family home and a duplex. Additional considerations include, firstly, ensure that the electrical design meets all applicable code requirements, including the proper sizing of service conductors, overcurrent protection, and grounding. Secondly, obtain all necessary permits and inspections from the AHA. And thirdly, communicate clearly with the AHA, utility company, and builder to ensure that everyone is on the same page. When dealing with electrical installations and interpretations of the National Electrical Code, it is crucial to understand the specific requirements and common practices in your jurisdiction. The NEC is a comprehensive set of guidelines designed to ensure the safety and proper functioning of electrical systems. However, its interpretation can vary among different authorities having jurisdiction. One common area of confusion involves the rules surrounding services and feeders, particularly when dealing with multiple buildings on a single property. Let's delve deeper into the distinctions between services and feeders, the relevant NEC sections, and the factors that influence how these rules are applied. A service is defined as the conductors and equipment used to deliver electrical power from the serving utility to the wiring system of the premises served. It is the main connection point between the utility's infrastructure and the customer's electrical system. The service includes the service drop or service lateral, the service entrance conductors, and the service equipment, such as the main disconnect and overcurrent protection devices. Feeders, on the other hand, are the conductors that extend from the service equipment to various distribution points within a building or to other buildings in the same property. Feeders carry power from the service to subpanels, individual loads, or other electrical systems. They are typically protected by overcurrent devices at their origin and may have additional overcurrent protection further downstream. The NEC contains specific requirements for services and feeders, including rules for sizing conductors, providing overcurrent protection, and ensuring proper grounding. These requirements are designed to prevent overloads, short circuits, and other electrical hazards. Section 230 of the NEC covers services, while Article 215 addresses feeder requirements. One of the key principles in the NEC is that each building should be served by only one service. This requirement, outlined in Section 230.2 A1, aims to simplify the electrical system and reduce the risk of confusion or unsafe conditions. However, there are exceptions to this rule, such as when a building is so large that it requires multiple services to meet its load demands, or when there are specific needs for emergency or standby power systems. When multiple buildings are located on the same property, the NEC provides guidance on how to supply power to these buildings. In many cases, it is permissible to run feeders from a single service to multiple buildings provided that certain conditions are met. Firstly, the service must be sized to accommodate the total load of all the buildings being served. This requires careful calculation of the demand loads for each building, taking into account factors such as lighting, appliances, heating, and cooling. Secondly, each building must have its own disconnecting means and overcurrent protection at the point where the feeder enters the building. This allows occupants to energize the electrical system in their building for maintenance or in case of an emergency. It also ensures that any faults or overloads within one building do not affect the electrical system in other buildings. Thirdly, the feeder conductors must be properly sized and protected to carry the load to each building. This includes considering the length of the feeder, the ambient temperature, and the type of insulation used on the conductors. Voltage drop should also be taken into account to ensure that the voltage at each building remains within acceptable limits. In situations where a single-family home is subdivided and a duplex is built in the rear, the question of whether to install a separate service for the duplex often arises. From a strict interpretation of the NEC, each building should have its own service. However, many jurisdictions allow for a single service to feed both buildings, especially if the buildings are considered to be under single management or ownership. In these cases, the main service is typically located at the original single-family home, and a feeder is run underground to the duplex. The feeder is sized to handle the load of the duplex, and a disconnecting means and overcurrent protection are provided at the duplex. This approach can be more cost-effective than installing a separate service, as it avoids the need for additional service equipment and utility connections. However, it is important to ensure that the existing service is adequate to handle the additional load of the duplex. If the existing service is undersized, it may need to be upgraded to accommodate the increased demand. Before proceeding with any electrical work, it is essential to consult with the local authority having jurisdiction. The AHJ is responsible for enforcing the NEC and other applicable codes and standards. They can provide guidance on how to comply with the code in your specific situation. The AHJ may have specific interpretations or requirements that differ from the general provisions of the NEC. It is also important to work with a qualified and licensed electrical contractor. An experienced contractor can assess the electrical system, perform load calculations, and ensure that the installation meets all applicable codes and standards. They can also assist with obtaining the necessary permits and inspections. When communicating with the AHJ, it is helpful to present a clear and well-documented proposal. This should include a detailed description of the electrical system, including the size and type of service, the feeder sizes, and the location of disconnecting means and overcurrent protection devices. It should also include load calculations that demonstrate that the service is adequate to handle the total load of all the buildings being served. If the AHJ has concerns about the proposed installation, be prepared to discuss them and offer solutions. It may be necessary to provide additional information or make adjustments to the design to address their concerns. In some cases, it may be possible to obtain a variance from the AHJ if strict compliance with the code is not feasible or practical. A variance is a written permission from the AHJ to deviate from a specific code requirement. To obtain a variance, you typically need to demonstrate that the proposed alternative will provide an equivalent level of safety and that strict compliance with the code would create an undue hardship. In addition to the NEC, it is also important to consider the requirements of the local utility company. The utility company may have specific rules and regulations regarding service connections, metering, and other aspects of the electrical system. It is important to coordinate with the utility company to ensure that the installation meets their requirements and that the service is properly connected. In summary, when dealing with multiple buildings on a single property, it is important to understand the distinctions between services and feeders, the relevant NEC sections, and the factors that influence how these rules are applied. It is also essential to consult with the local authority having jurisdiction and work with a qualified and licensed electrical contractor to ensure that the installation meets all applicable codes and standards. By following these guidelines, you can ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Remember to always prioritize safety when working with electricity. If you are not qualified to perform electrical work, it is best to leave it to the professionals. Electricity can be dangerous, and improper installation can lead to fires, shocks, and other hazards. Taking the time to understand the code and working with qualified professionals is the best way to ensure a safe and compliant electrical system.